Have you ever wondered how AI chatbots like ChatGPT actually work? It all comes down to a revolutionary idea in machine learning called the transformer, a type of neural network introduced by Google in 2017 that has completely changed the way machines understand and generate language. Let's break it down. Generative Pre-trained Transformers, or GPT. The name says a lot. These models are generative, meaning they can generate new text, pre-trained, having learned from a massive amount of data before being fine-tuned for specific tasks. You can check out my video on fine-tuning and retrieval augmented generation, and they are based on the transformer architecture, a powerful structure that allowed AI to leap forward. Originally, transformers were designed to help with things like translating one language to another, but their use has exploded into all sorts of tasks: answering questions, writing essays, generating code, summarizing documents, and more. This is because they were able to predict the next word, and once you can predict the next word, you can use the same technique to generate text in a passage. So how does a transformer generate text? Number 1, tokenization. Everything starts by breaking input down into tokens. These are chunks of words, sounds, or images. For text, it could be whole words or even just parts of words. Each token is then turned into a vector, a list of numbers that captures its meaning. Imagine each word floating in a high-dimensional space, and similar words land close to each other in this space, as I'm going to talk about shortly. And secondly, there is the attention mechanism. These vectors pass through what's called an attention block. This is where the magic happens. The model figures out which words in the sentence matter more to each other. It's like asking, which other parts of this sentence should I pay attention to when thinking about this word? This gives the model the ability to understand relationships and context, even for words far apart in a sentence. Then we have the feed-forward layer. The vectors are passed through a multi-layer perception, basically a lot of math that updates each vector based on learned patterns. These calculations happen in parallel, helping the model build deeper understanding. Then repetition. The process is repeated across many layers, like refining a rough draft multiple times. Eventually, the model has built up a rich understanding of the whole passage. And finally, prediction. At the end, the last vector is used to predict what comes next. It gives a probability distribution over all possible next tokens. The model picks the most likely next word, adds it to the text, and repeats the process to generate more. So how do chatbots use this? When you talk to a chatbot, it starts with a system prompt, something like, "This is a conversation with a helpful assistant." Then it adds your question and uses all this machinery to predict the best possible response. That's how it seems like the model is talking back to you, but really, it's predicting what a helpful assistant might say next. And the role of machine learning and training? The model learns this through deep learning. Imagine you're trying to predict house prices. You use a simple model like linear regression, where you learn the best slope and intercept to fit a line to data. It may be based on square footage and price. You adjust those values based on examples. GPT works the same way, just with billions of parameters. In fact, GPT-3 has over 175 billion parameters, while GPT-4 was trained on a whopping 1.76 trillion parameters. So the parameters are like knobs the model can adjust to get better at predicting. Training involves showing it millions of examples and tweaking those parameters until it gets really good at guessing what comes next. It uses an algorithm called backpropagation to figure out how to make those changes. It takes into account how the changes on the weight or biases of a model affect accuracy. You visit the model based on that. Every little improvement adds up. The core data in transformers are vectors and weights. Vectors encode the meaning of each token, while the weights are the model's learned parameters. They determine how the input gets transformed at each step. There are different types of matrices involved. The embedding matrices turn tokens into vectors. The query key and value matrices power the attention mechanism, and the output, projection, and unembedding matrices help produce the final prediction. These matrices are huge. For example, the GPT-3 has embedding matrices of size 50,207 by 12,288, which leads to over 600 million weights just in the embedding layer. So how is word meaning captured? These vectors aren't just random numbers, they actually capture meaning. For example, the vector of mother minus father is roughly the same as woman minus man, and Batman minus Bruce Wayne is similar to Superman minus Clark Kent. And one that I got from the 3 blue 1 brown visual explanation was something like Germany minus Italy will be synonymous to Hitler minus Mussolini. These differences represent concepts like gender, geography, or time, and the model learns to associate directions in space with semantic meaning. Even more impressively, it can represent things like plurality. Cats minus cat will give a direction that can be compared to dogs minus dog. And at the final stage, the model uses something called softmax to turn raw prediction, called logic, into probabilities. This function turns any set of numbers into a list between 0 and 1, where everything adds up to 1, just like a probability distribution. It uses Euler's number E, power the value of the weight to get a positive number, say x. You divide x by the sum of all weights in the column, and you'll get values between 0 and 1 for each token, normalizing the values. To make text more or less random, the model can adjust the temperature. Lower temperature makes it pick more predictable words. High temperature adds creativity, but if you make it too much, it can lead to nonsense. So a temperature value of 2 is normally the max you can apply to prevent making the model nonsensical. For the limitations, one limit of the models is context size. They can only remember a certain number of tokens at once. GPT-3, for instance, can handle around 2048 tokens. That's why older versions of chatbots felt like they forgot things you had said early in a long chat. Newer models, GPT-4, GPT-01, have larger context windows and better memory systems. So in summary, transformers are the brain behind modern AI. By converting words into vectors, applying the attention mechanisms, and using deep learning to adjust billions of weights, they generate text that sounds human. Whether it's translating a sentence or helping you brainstorm ideas, it all does prediction, powered by math, data, and the mighty transformer.